Okay, good morning, students. Today's class is a very special class because we want to answer this question. Is artificial sun possible on land? क्या कृत्रिम सूर्य जमीन पर संभव है? इस स्लाइड में आपको जो पिक्चर दिख रही है वो हमारा नेचुरल सन है, ठीक है ना? अब हम कोशिश करते हैं इस क्वेश्चन को आंसर करने के लिए. सो द रोड मैप ऑफ दिस सेशन इज first we will see the power of sun, right? How much power is available in the sun and how much we are getting. Then we will discuss the two important nuclear reactions, right? And then we'll see what is the difference between these two reactions. Then after we'll see the installed capacity of nuclear power in India. And then finally we will be able to answer the question, is artificial sun possible on land? So the first slide, the sun powers all life on our planet just like all stars. It produces unlimited energy through a process that is known as fusion. We'll discuss what is fusion in our next few slides. At any moment, the sun emits a huge amount of energy, and that is equivalent to 3.86 into 10 raised to power 26 watts of energy, right? So next come to the nuclear reactions. We all know that there are two important nuclear reactions. Number one is nuclear fission and number two is nuclear fusion. न्यूक्लियर फ्यूजन का मतलब होता है नाभिकीय विखंडन और न्यूक्लियर फ्यूजन का मतलब होता है नाभिकीय संलयन. So first we will discuss about the nuclear fission. Actually, fission is a process in which heavy nucleus split into smaller nuclei. Here in this slide you can see that the main fuel in this reaction is uranium, and this uranium is bombarded with neutron, and byproducts are barium and krypton, and we will be getting the energy. It is basically a chain reaction. Nuclear fusion is just opposite reaction where the light nuclei combine to form a single heavier nucleus. In this case, the main fuel is deuterium and tritium. Sometimes this equation is also known as DT reaction. Here the main fuel is deuterium and tritium. These are basically the isotopes of hydrogen. In this case, we are also getting the energy. So both the equations we are getting energy, but there are some differences. The first difference is the natural occurrence of the process, whether this process occurs naturally or not. So basically nuclear fission, it does not occur naturally in the nature, and as far as fusion is concerned, it naturally occurs in sun and in stars, right? As far as their application is concerned, uh, right now in all over the world, in all nuclear power plants which are used for the power production are based on nuclear fission reaction, right? Please take a note of that, because nuclear fusion there are certain issues. So uh, up to the recent time it is an experimental technology, and at lab level we are producing the energy, right? One more important point, you can note down this: in case of nuclear fusion, more energy is produced as compared to fission, right? So please take a note of that. So first, in the next slide, we'll see the installed capacity of various power plants in India, and then we will answer uh, why the nuclear fusion is not used for the power production. In spite of that, the in this equation or in this reaction, more energy is produced as compared to fission. This slide is basically showing you the current installed capacity in India. These data are very recent data up to 31st of December 2021, and I have taken this data from authorized website of our country, that is CEA, that is Central Electricity Authority of India. Here you can see that 393 gigawatt is the total installed capacity in our country. right? So the thermal portion is around 59.6%. Thermal means the coal and gas, right? Diesel power plants, etc. Hydro accounts around 12%. Nuclear, you can see that a very less amount of energy we are getting from nuclear power plants. And I have written especially fission because from fusion, as of now, we are not getting any kind of energy, right? Here, RES stands for renewable energy sources like solar, wind, uh, etc. Right? And it accounts around 27%. So next, here our next slides are mainly focused on the nuclear fusion. Right? Earlier, we have said that in case of nuclear fusion, more energy is produced as compared to fission. But right now, as on today, we are not able to utilize the fusion reaction for the power production. In spite of that, it has more energy as compared to fission. So, in our next slide, we'll see what are the issues which are related to the nuclear fusion and why we are not able to utilize this particular reaction for the power production. So earlier we have seen that in case of fusion, the fuel is deuterium and tritium, right? And we have said that these are the isotopes of hydrogen. So both are positively charged atom, right? So, and we know that when these positively charged particles are uh, combined to each other, then a huge electrostatic repulsion is there as they come close together, right? So, in order to have the nuclear fusion reaction, we need a strong nuclear force which can overcome the repulsion force, right? So, in order to have the fusion reaction, we need high temperature and high pressure, right? So, you can imagine that how much amount of temperature and pressure is required for the nuclear fusion reaction to occur and to have a sustainable reaction rather, right? So around 100 million degrees Celsius temperature, 100 into 10 raised to power 6 degrees Celsius temperature. So you can imagine a huge temperature which is 6 times hotter than the core of the sun, right? And second is we need a high pressure which is greater than 2 atmospheric pressure, right? So here the main thing is how this high temperature is obtained, and second thing is the container in which this reaction takes place uh, should be capable or should withstand such a high temperature, right? So these are some issues with the nuclear fusion reaction. That's why as on today we are not able to produce this energy in the field level, right? The research is carried out on from decades, but till now it is at research level and the energy is produced only at the laboratory level, right? Now come to our main point that we have uh, basically uh, selected for this particular session. Is artificial sun possible on land, right? क्या जमीन पर कृत्रिम सूर्य संभव है? चलिए देखते हैं इसका आंसर आगे. So yes, China's extremely powerful artificial sun is now switched on. Recently, uh, on 4th of January, this news was published in indiatimes.com, and you can see the link is available here. So now let us see what China has done, right? So, according to the state-run Zhonga News Agency, it is a major channel for the distribution of information in China. Recently said China's experimental advanced superconducting Tokamak, that is EAST, is experimented successfully. Here, what is Tokamak and what they have done uh, exceptionally, we'll see in our next slides. So, first of all, see what is Tokamak. Tokamak is basically a nuclear fusion reactor which is based on the principle of plasma uh, magnetic confinement, right? So first, let us try to understand what is plasma type of magnetic confinement. Actually, we have said that for nuclear fusion reaction to occur, we need lot of temperature and pressure, and at this temperature and pressure the material is converted into plasma, which is the fourth state of matter, right? And plasma is basically the ionized gas, right? And at this stage the particles move randomly, right? If we do not confine these ionized gas, then particles randomly move here and there, and they will strike to the walls of container and lose their energy, right? So sustainability of the fusion reaction is a big issue, right? So two types of confinement techniques are basically used to confine the plasma, where number one is magnetic confinement and second is inertial confinement. So right now we'll focus on the magnetic confinement. As far as magnetic confinement is concerned, we know that the charged particles are very difficult to escape from the magnetic field. So this technology is used in Tokamak reactor. So the artificial sun called EAST is a nuclear fusion reactor, and they have claimed that in this reactor 70 million degrees Celsius temperature was achieved and it was sustained for 17 minutes, right? The sun's core in the contrast reaches temperature of around 15 million degree. So they have claimed that they have reached the temperature which is 5 times hotter than sun, right? So let us discuss about this project. This project was started in 2006 and has a cost of $943 billion. So you can see how much Indian rupees are there, and this experiment is expected to run until June 2022, and about 10,000 scientists are working together for the success of this project, right? But some scientists still believe that the nuclear fusion could help humans maximize clean energy production, but the development of such a technology is extremely difficult. And even after decades of research, this reaction can only generate energy in lab settings. But if the claim holds weight, it could revolutionize the way China creates and absorbs clean energy, because the main goal is to deliver endless supply of clean energy by imitating similar reactions that takes place in our sun, that is nuclear fusion. So thanks a lot, and please have a nice day.